I cannot be too fast on this, if I go too fast, I cannot really write it down on this board. That's the thing. But you can do it. It's okay, even if I'm doing it slow, you can continue doing your copy and you can get the answer. So you have
Sir,
this.
your voice is too low.
It's very low, right? Yeah, just okay, let me just check once. Okay. Uh, is it it's still low?
No, sir, it's fine.
Okay, okay. Okay, so if we just look into this, let's say, you have a circle which is defined. There you can actually find out the center, because it's x minus x1 whole square plus y minus y1 whole square is equal to r square. That's how you define the equation of a circle. And from these kind of equations, you can actually know what is the center. So 0 0 is the center here, right? And then radius is equal to 4. So that means if we just want to limit the expression, and this is something which we have done at the beginning, we can actually write it down as modulus of z is equal to 4. Okay. And if we want to use the Cauchy integral theorem, we have to find out a single numerator denominator, which is can be written as z minus a. So z I have to divide by 0.5. So what I can do is I can just do it this way: 1 divided by 0.5, and then I integrate this. Okay, and this is z square plus 8, and then this is z minus 1.5 divided by 0.5 into z, right? So we can have it that way. Okay, and dz, I'll just put dz there, and then 1 divided by 0.5 is 2, integration c, this is z square plus 8. Okay, and then this is nothing but z minus 3. Okay, oh sorry, I think I put a z there extra. It's not needed, obviously it's not there. This z is not there. Okay, so we have got the value of a, and then eventually we can actually use the Cauchy integral formula. Okay, so z is equal to 3, and this basically lies inside the circle, lies inside, right? So whenever you are doing it, you have to first check whether it lies inside the circle or not. If it does not lie inside the circle, you can straight away say that it's the 0. You don't need to integrate this anymore. Here it's z is equal to 4, so that means it will be having a radius of 4. So this is 3, so it will lie inside this. I'm also going to show you some special examples, okay, but that we'll do later. Fz is equal to z square plus 8, and we can just simply write it down as 2 times of fz divided by z minus 3 dz. Okay, is equal to 2. So this 2 is there, and then fz divided by z minus 3, that means it is 2 pi I f of a. A is 3 here, so I can write it down 2 pi I f of a. My a is 3. Okay, you can just recall this, we have done it last week. Z minus a and fz. So fz for my case is z square plus 8, so you can just replace it, right? So it is 2 into 2 pi I into z square. Okay, so that means 3 square plus 8. So it's simple, right? I think you can do 9 plus 8 17. 17 into 4 is 68, right? So it is 68 pi I. So these kind of problems will be there, and you will be doing it. Okay, and partial fraction is also very important, because last time we have actually seen some examples here. Let me do one more example based on partial fraction, okay, where we have got 3 factors a, b and c. So let's just do it. Okay, so 4 minus 3z, that's your f function. Okay, and at the bottom we have got z, z minus 1, z minus 2. So the more examples we solve in class, the more you practice on your own, these things are going to be easy. 1.5, right? So we have this, okay, and we can just take this, let f z is equal to 4 minus 3z. That's my function node. And then we can actually find out the partial fraction. So let's just do it. 1 divided by z, z minus 1, z minus 2, right, can be written as a divided by z plus b. You already know a technique which is actually a longer technique to find out the partial fraction. In these problems, whether you do it for your entrance exam or even for your class exams, no one is going to ask you, what is the technique for doing the partial fraction in detail. So you can always do it in short. Okay, the first thing is, let's say a divided by z. So don't consider this z and then consider the other two, right? So what you can do is, if you want to find out a, I told you that technique the other day. So you can say it's 1 divided by z minus 1 and z minus 2. Okay, and this will be equal to your a. Okay, and how can I write down this? What will be my value of z? Whatever is at the denominator of a, that means z, equate it with 0, and then see what is the value of z. So you're getting the value of z is 0 if you equate z with 0. So that means you can just put z is equal to 0, 0 minus 1, 0 minus 2, it is minus 1 minus 2, it is 2. So that means a is going to be half. That's actually the easiest and the most convenient way, and it works most of the times. It does work. So I'll take it again
Oh,
for, yeah,
so the answer is 2 pi I.
2 pi I. Let me just confirm. Yeah, answer is 2 pi I, right? Okay. So for b it is z minus 1. B z minus 1, so I can ignore this z minus 1. Just remember this technique. Okay, we've just done one problem on partial fraction, so if you really don't recall the longer process, you can remember this whatever I'm saying, and they should work. So z minus 1 you ignore and take the other two. So I can just take up z into z minus 2 is equal to b. I have to just write down what is the value of z. So in the second case it is z minus 1 is equal to 0, so z is equal to 1. So if I do that, I can get 1 divided by 1 minus 2, it's 1, and then 1 minus 2 is minus 1, so it is minus 1, so b is minus 1, right? Similarly, if you do for c, you should get the value to be half. Okay, so do it. Okay, you have to practice it once or twice, and then you should be able to do it. So therefore, if I just want to write down the integral, okay, I can just simply write it down as fz, and then I'll get three values here. Okay, one is half by z. Okay, or maybe I can just simplify it and write it down as 1 divided by 2z. Okay, then minus, because p is minus 1, z minus 1, then plus c is again half, so I will write it down as 1 divided by 2 into z minus 2. So I've got three factors now. Then now I can easily do it. Okay, and I hope you remember that if you put the value of a, b and c and take the LCM and do your calculations here, you should be getting back this one. Okay, if you're confused, you can just try and see. During exam time, sometimes you feel that might be you're wrong, you always use that process. Okay, so let's do one factor by each, one by one. So it is half. I can take out half from the first factor, so it will be just left out with fz divided by z minus 0 minus 0, and this is dz. Okay, and then I can take minus, and this will be integration of again fz divided by z minus 1 dz, then plus integration, and this is again half fz divided by z minus 2 dz. So here what we can do is we can actually use the Cauchy integral formula, and that's the benefit we have when we know Cauchy's integral formula. So this is fz, we know it is 4 minus 3z, so this would be 2 pi I into f of 0. So this is 2 pi I into f of 0. So what is my 0? I can just put in place of z as 0, so this will be just 4. So I'll directly do it. I'll put 4 here. Okay, this is 1. And look at this final one. Okay, see here in this particular case, z is equal to 2. In this particular case, z is equal to 2. So z is equal to 2 is something which lies outside. It lies outside the circle. Okay, so this is the thing that Cauchy integral actually helps us to solve. Lies outside the circle. This is z is equal to minus 1.5, right? So it should be within 1.5. So that means this term will actually become 0. I don't need to do anything here. I'll just do this term. So this is minus, and then you can just take it to be 2 pi I. Okay, 2 pi I f of 1. F of 1 means, f is this, so z is 1, so it is 4 minus 3 is 1. So I can just take it to be 1. So this 2 and this 2 gets cancelled. 4 pi I minus, 2 pi I. We do it, we'll get the answer to be 2 pi I. Now let me just tell you one thing here, that this is only not the one technique that you have to solve. We are using Cauchy integral formula to solve it. Eventually you will see there is something else which is called the Cauchy residue theorem, and there also we can do it. Even if we don't know about Cauchy integral formula or Cauchy residue theorem, still we can solve it. Okay, you can just use normal integration and solve it. There is no harm in doing that also. But the thing is, when I'm asking you a question, in mathematical physics, probably I'll mention use Cauchy integral formula, use Cauchy residue theorem, and so on. Now, before we proceed, to the next question, I'd like to tell you something here, that when you do it for your normal exams, and if I'm not mentioning whether integral theorem or residue theorem, you can use either of them. But when you do it for your entrance exams and all, to take things faster, you can always use residue theorem. So we are going to check residue theorem today, and we can actually solve the same problem using the residue theorem as well. Okay, but before that, if you remember, when we actually started with the Cauchy integral formula, I give you some differential values and I put it inside notes. Okay, I'm just going to take one example here, and we are going to solve one more. It will take even less time if we use that formula. In general, if to do it step by step, but then in general it's not very difficult if we use that formula. So e to the power 2z into z plus 1 to the power 4 dz. Okay, and your z value is 2. Okay, this is the integral that we have to do. Okay, and if you remember, when we actually were stating Cauchy's integral formula, we actually did the differentiation and found out something. What we found out was that if we write it down as f of a, f of, this is z, f of z divided by z minus a, and if we differentiate it n times, so you will get a power of n plus 1 dz. If you don't remember, please refer to the first lecture we had on Cauchy integral theorem, and you will see that we have actually already done it. Okay, so this is 2 pi I into n times differential, okay, and a divided by factorial n. We have already derived it. Okay, so please check it once, and if you check it, you'll see that it's there. Okay, we're going to use this now. What is the reason? Because we have got z plus 1 to the power 4. There is a power 4 there. Okay, and that's why I want to use this formula. Okay, so that is the application of that particular formula that we have written in notes. So although we might do only one or two questions, but we will actually see that there are so many problems that can be done using this. So this is n plus 1 is equal to 4. Okay, and if n plus 1 is equal to 4, n is equal to 3. Okay, n is equal to 3. So we know what is n, how many times we should differentiate it. So let, okay, fz is equal to e to the power 2z. Okay, this is fz, we have already defined it, and z is equal to minus 1, because z plus 1 is equal to 0. That means z is equal to minus 1 will lie inside, right? It lies inside. So these analysis we have to do first before we really solve the problem, right? If you actually want to draw a circle for this, you'll sometimes see you don't need to really draw a figure. Sometimes it will help to draw a figure. We will actually see that later. So Z is equal to 2, center is 0 0, radius is 2, this is 2, this is minus 2, so this is 2 0, right, this is minus 2 0 and so on. So it lies inside. Okay, so it's simple. So what you can do now is we can integrate it. So I'll just simply put it as fz divided by z plus 1, a is minus 1 for us, to the power 4 dz. So you can compare with this, you can compare, compare this and compare this. You see the value of a is minus 1, so we can take that value. Okay, and we can use this formula. So what is the formula? This is 2 pi I f, n is 3 in our case, so it's 3, that means 3 times we have to differentiate. So I'll just put triple dash and a, so the a is minus 1, so I'll just put minus 1. I'll do it directly, divided by factorial n is 3, so it will be factorial 3. So that means if I just solve it, it is 2
So I by 3 is square.
e square.
No. 8 pi I by 3 into e
e
square.
to,
E square.
okay, I don't know, let's just check it once. Okay, so this is 2 pi I divided by 6. Okay, and we have to triple differentiate your e to the power 2z, right? So once you do, you'll get a 2z in front, another time you do another 2z in front, another time you do another 2z in front, so it will be 2z into 2z into 2z, so that means this would be 8z cubed. Okay, and then e to the power minus, e to the power 2z, that will be the differential value, right? And then you have to find out at z is equal to minus 1, right? So you'll just replace it. Let me just simplify this. Let me write down 3 here. So this
Sir,
will be pi, yeah,
z
yeah,
will not come here, no?
uh-huh,
No,
So
only
the z
8, sir.
cube 8. Sir, it will
Only 8.
only be the 8, no?
yeah, z is equal to minus 1, I have not yet put, so I'll put it now.
No, sir, it is
Check it.
only 8. Like 8 e to the power 2z.
Oh,
Okay.
sorry, yeah, sorry, absolutely, yeah, right, correct. It's only 8, right? Yeah, absolutely. Just 8. So this is 8, and then e to the power z is minus 1, so I'll just put minus 2, right? So yeah, whatever answer you got is correct. So this is 8 pi I e to the power minus 2 divided by 3. So this Cauchy integral theorem makes things so simple. If we just use conventional technique to actually solve it, we have to consider it either a two function system and then keep on differentiating and then making a series and then solving it. Take a lot of time. But then if you use this Cauchy integral theorem, straight away you're getting an answer here. So it becomes simpler, much simpler. Okay. So that's actually the benefit of Cauchy's integral theorem, and it's not only for these kind of problems. Like if someone even doesn't mention that you have to use Cauchy's integral theorem, you can still use it and find it. There is no harm in doing it, because I've seen in entrance exams sometimes they really don't mention, okay, that whether you're supposed to use or not. The main aim is to find out which option is correct. So you will use whatever technique will take minimum time. So eventually you will see that Cauchy's residue theorem is going to take minimum time, but Cauchy's integral theorem is in our syllabus, so we cannot really think about time and all. We are just going to solve it. Okay, so I'm going to give you this problem. This I'll give it to you. You can solve it now. Sin z divided by z minus pi by 6 square. So n is equal to n plus 1 is 2, so n is equal to 1. You have to use the same technique that we have done in the last sum. Dz is okay, and the circle is z is equal to 1. Okay, so let me give you around 2 minutes. 3 pi I should do it. Okay, so I have been yes, Cauchy's residue theorem की बहुत तारीफ कर रहा था मैं. So let's just look into it. Okay, we'll just look into the theorem first, and then probably we'll shift to the numerical problem. So this is also very important because it has got different parts of question based on this. There are questions you've seen in entrance exams that they will ask about poles. They will ask you to find out the residue, okay, and so on. So these questions are very common. and everything comes out from here. Okay, Cauchy's residue theorem will help you to know everything. Okay, so let me just give you the statement here. Okay, uh, most of the times, we are defining these things in terms of analytic function. So let's say if fz is, I suggest all of you please write this down. Okay, keep this statement handy. If is fz is analytic function, uh, exam don't write down in short. Okay, I'll suggest you write down properly inside and on a simple contour, closed contour. Okay, so we basically have got a closed surface, and we are saying that f dash is actually a function within that. Okay, and this is more or less analytic. Okay, and it's not that it will be analytic everywhere. Okay, contour C, it may be at certain positions it would be analytic. Okay, except expect sorry except except at let's say there are finite number of points in which it is not analytic. Okay, and I just ask you to recall Cauchy's theorem. Okay, number of poles. Okay, poles, we'll see what is pole and all. I think we already know it, but then we're going to look into some problems. These poles are, these are singular points. Let's say these poles, let's say z1, z2, z3 inside C. Then we can take the integration C f z dz. We want to find out the integration of that function. We can just simply write it down as 2 pi I r1 plus r2 plus, depends on how many residues are there, rm. We're going to solve it, but before that I'd just like to recall Cauchy's theorem. Okay, not the integral formula, Cauchy's theorem. It says that if we basically have this is a closed contour C, and we have got a function inside it which is analytic, then this integration of fz dz is equal to 0. That was Cauchy's theorem. Okay, if you have it within this, and if this fz is analytic, we already know how to know whether it is analytic or not. U plus iv is equal to 0. If you remember, we did it. So this is basically nothing but giving a result as 0. But then if you have this contour here somewhere, and the function is there, but at certain points, let's say z1, z2, z3, this is not analytic. So if this is not analytic at all the points, this cannot be equal to 0. If this is not analytic at all the points, then the function fz tz will have some value. Okay, so this is what it means. And what will be that value? I can simply write it down as 2 pi I into the the residue. So now we are going to see how to find out the pole, order of the pole, how to know whether it is a simple pole or not, and then how to find out the residue. Very, very important. Every year, one or two question is actually must from this particular topic. Okay, whether be it your entrance exam or normal exam that I'm taking up. Okay, everywhere you'll get these kind of questions. Okay, so the first thing is what are poles? Okay, so poles are basically the points where the function is not analytic. Okay, or maybe I can write it down here, where function is not analytic. So that's a pole. Okay, so if I say that this is not analytic at z1, z2, z3, that means this is going to give you some kind of value which we have written. Okay, and if it is analytic, everywhere it is analytic, that means the function is going to be this. Okay, which is actually as per the Cauchy's theorem. Okay, so that's very important. And one more thing that we should note, what are r1, r2 and all. This is the notation that I have used first time. So these r1, r2, rn are basically called the residues. Okay, so these are called residues and poles. So these are residues and poles. Okay, so these are important points, and then I will just give you some more notes, okay, which are also important, and we're going to use it eventually later. Mm, so the first thing is we have got something which is called a simple pole. So when I'm going to tell you simple pole with example, but then if the values are not repeated, it's basically a simple pole, okay, in general. Otherwise it will basically be a pole of some order. So the residue at simple pole, simple pole at z is equal to a. Okay, this is one point, let's say. And if you want to find out the residue, this would be residue at z is equal to a, okay, is equal to limit z tends to a. So you are going to use the limit also here. So certain theorems, limit theorem, how to use limits and all that also you should know. F of z. So that's your for simple pole. Okay, there can be one more thing, whether pole is not simple, it will have some order. So I can write it down as residue at a pole of order, let's say n. Okay, so we have got a pole of order n. There also we can find out the residue. So let's see, residue at z is equal to a. These are all important. I have to just remember it once, and then I think you can put it into good use. 1 divided by factorial n minus 1 into d of n minus 1. This is the order, okay, third order, second order, and so on. D z of n minus 1 into z minus a to the power n f of z. That's the second thing that you should remember. Okay, this is a very important slide. I suggest all of you to remember this. Maybe you can take a screenshot and keep it with you. So the third one is, this is all important points that you need to understand: residue, pole, and how to use the Cauchy residue theorem. Okay, and then finally we can actually also find out the residue at infinity. Residue at infinity. So if we have that, residue will be limit. We'll take examples and then it will be more clear. Tends to infinity. This is minus z f z. Okay, so that's how you take the residue at infinity. So these are the important paths that you should remember when you actually are going to do problems on residue, pole, or find out the integral value using the Cauchy residue theorem. Okay, and it's incomplete without doing some problem. Okay, and you have to remember that whatever problem you can actually solve using Cauchy integral theorem. So if you are solving a problem using Cauchy's integral theorem, what we did in the last topic, okay, integral theorem, you can actually solve the same problem using the Cauchy residue theorem. So until and unless it's mentioned specifically that which formula you should use or which theorem you should use, you can use any one of them. And what I would suggest is understand Cauchy's residue theorem, because for entrance exam point of view, residue theorem helps better, because it can help you to find out your calculation much faster. So in that way it's good. Okay, in a way it's good. So let's just try to take out some problems. Okay, let's just do few sums here. Okay, and then we will have more confidence on how to use the residue theorem and so on, find the poles and everything. So there can be different types of questions. I'll just take up one kind of question. Let's say find the Let's start with something which is very simple. Find the order of each pole and their residue, maybe. Just write it down as residue. Okay. Of, so I'll be given a function and then I have to find it then. Okay. So maybe it's 1 minus 2z divided by z, z minus 1, z minus 2. Okay, so this is your function, right? Now, what we can do is, first we have to find out the poles. Okay, first we have to find out the poles. So what we can do is, we have got z z minus 1, z minus 2, we can equate it with 0, and since all of them are independent, we know that z can be 0, z can be 1, or z can be 2. Now neither of them are repeated. Say it is 0 is only once, 1 is only once, 2 is only once. So neither of them they are repeated, hence they are simple poles. Hence these are called simple poles. So as soon as we know that the poles are simple, we know which formula to use to find out the integral value. However, the integral value is not asked here. We are not going to find it out right now. Okay, simple poles. Okay, so I'll just write it down as a note. I think I should write it down as a note. Don't include it in your exam when you write down the answer to a question. Since no z values are repeated, so they are not repeated means they are simple poles. So the question might be, identify whether they are simple pole or not. Okay, that can be a question. So in general, if I just want to find out an order of each pole, it's just one, because it doesn't get repeated, so it's just one. So you understand that. And now suppose I want to find out the residue. It's very simple. It's simple poles. So for simple pole, I'll use the formula limit z tends to a. In the first case, my a is 0. Please recall this. So I'll put z tends to 0, and then the formula is z minus a. So I'll put z minus 0 into fz, the entire function. So this is my function. Please remember now, don't get confused and say that only the numerator is the function. No, the entire term is the function here. Okay, so this will be 1 minus 2z
Hello, sir.
divided by, yeah,
Sir, for the first case, that means z equal to 0, we are getting the residue as half,
correct.
and z equals to 1, we are getting the residue as 1, and for z
Uh-huh.
equal to 2, we are getting the residue as minus 3 by 2.
Correct. Right. Okay. So you can do it. Very simple. So cancel this. Put the value of z as 0. So this is 1 minus 2z. So that is 1 divided by 0 minus 1 is minus 1. 0 minus 2 is minus 2. So you can get it to be half. That's it. Right. Similarly, we can actually find out the residue R2. This is limit, and this is z tends to 1. And then we can just simply write it down as z minus 1. And once you keep on doing this, you'll have a habit of doing it automatically. Everything comes out mechanically. It's not very complicated. You have to just remember the formula. That's it. Z minus 1 gets cancelled. I'll just put the value as 1. So this is 1 minus 2. So that's minus 1, right? Minus 1 divided by, this is 1. So 1. And this is 1 minus 2 is minus 1. So minus 1, again it will be minus 1. So this will just come out to be 1. So that's R2. And if we just find out R3, it is limit z tends to 2 now. Okay, 2. It's also a simple pole. Simple pole, don't need to differentiate. If it's not a simple pole, you have to differentiate. That's it. Okay. Sorry, 1 minus 2z 2 to z into z minus 1 into z minus 2 gets cancelled. I'll put z is equal to 2. 1 minus 2 into 2, 4. So that is minus 3 divided by z is 2. As 2 minus 1 is 1 and 2 2 2, so it is minus of 3 by 2. So these are the three residues that basically you have. Okay, and although it is not asked in this question whether you are supposed to find out the uh, values or not, okay, but there may be a question like this. Okay, maybe I can just take this. My handwriting is going bad day by day, it seems. Okay, anyway.
Hello, sir.
Yeah.
Sir, the line can you please repeat once the hence simple poles in bracket as no z values are repeated. Sir, please again can you please tell
Yeah,
something
so what
about
we will
that?
do is we are going to take another example where it won't be a simple pool and that it will be easy. See, I mean no z values are repeated. It means that 0 appears only one, 1 appears, 2 appears. Okay, sometimes you might have something like this, z plus 1 square, and if you equate it with 0, you can write it down as z plus 1 into z plus 1 is equal to 0. So that means the z value would be minus 1, minus
Minus
1.
one
So there
two
are two
times
minus.
that. Okay, okay.
Yeah, so it will be a pole of order 2.
Hmm.
In simple words, we can say if there is a power, I can simply say that z is equal to minus 1 is a pole, but that order will be 2 because the power is 2. But to understand it better, I can simply write it down as z plus 1 and z plus 1 is equal to 0. So minus 1 value gets repeated, hence it is not a simple pole. That's the only difference that you have to remember. Okay, and this is something which we forget. If you forget this, the basic, there are some questions which you will miss out and you'll get confused. Okay, but anyway, I am actually going to do some sums which are not simple poles. But before that, let me just complete this question in every sense. Okay, you can be asked to find out the order of each pole for this particular question. Okay, and maybe you have to solve it. Okay, maybe you have to solve it. So solve it means you'll be actually given something like this: 1 minus 2z divided by z into z minus 1 z minus 2 dz. Okay, and this will be 1.5, z is equal to 1.5. Okay, now if you look into the previous problem, we have seen, and here also we can see z can be 0, z can be 1, and z can be 2. This won't be included because it's 1.5 and this is 2, so this doesn't need to be included. Now it means, okay, that R3 in this particular case, if you want to actually solve it, will be 0. Residue 3 would be 0 because this doesn't lie within the contour. Modulus of z is equal to 1.5. So this is a must. If this is not mentioned, you can do it for all. But if it is mentioned, you have to check whether it lies inside or not. Okay, that's very important. So therefore, if I just want to find out the integration, you see, it's so simple now. F z dz, in our case fz is this entire function 1 minus 2z divided by z into z minus 1 z minus 2. So this, if you check the formula, let me just revise this formula once for you. 2 pi I r1 r2 up to whatever residues you have. So that means I can simply write it down as 2 pi I, r3 for us is 0, r1 plus r2. That's it. R1 kaha gaya, half, R2 is 1, so it is 1 plus half, that means it is 3 by 2, 2 gets cancelled, so it is 3 pi I, right? So we can just say it is 2 pi I into, first one we got it as half, this one is 1, okay, and just solve it, right? If we just solve it, this is
3 by
3 pi I, correct, yeah, that is 3 pi I. Okay, so you have to keep a check of this is very important. Okay, and if you use Cauchy integral formula also, you are going to use if you basically, let's say I look into the function once, it's 1 minus 2z divided by this, and if you use this technique, okay, whatever we used here, or maybe this technique, you are going to end up with the same answer. But here you have to do your partial fraction and then only you have to find out ABC and then do the calculation and find out the answer. Here you have to just find out the residue, and if you practice, you will see finding out the residue takes much lesser time compared to finding out the partial fraction, or if you're solving a more complicated integration problem. Okay, so that's why I'm saying that Cauchy residue theorem is very helpful. But for your exam purpose, I will make sure that I actually mention that what method you are supposed to use. Okay, because the question has to be evenly divided in different parts of the chapter as well as different parts of the syllabus. That's very important. We've done one. Let me just do one more sum here. Okay, and maybe I can ask you to do it. Okay, this will be slightly longer, but you can try. Okay, the question is find the residue of fz, okay, is equal to, so looking into the function straight away, you can easily recognize that what exactly you're supposed to do, which formula you're supposed to use. Z square minus 2z divided by z plus 1 whole square, z square plus 4. Okay, this is the one that you are supposed to do. Okay, now this is not a simple pole. Let me just do it for you once. Not going to do the entire sum. I'll give it to you for doing, but then let me just tell you this: z square plus 4. Now you might equate it to 0, and then when you check here, this is z plus 1 square is equal to 0. That means if you just find out the value of z, you'll see it will be minus 1, power is 2, so that means twice. So it's not a simple pole, it's a pole of minus 1 and the order is 2. And then the second one would be z square plus 4 is equal to 0. So square it and take it on the other side. Z square is equal to minus 4. So that means z is equal to 2i and minus 2i. So these two values that we have, z is equal to 2i and minus 2i, are simple poles. Why? Because one is 2i, one is minus 2i. They are not repeated. Okay, so these two are simple pole. And we know what is the formula for finding out the residue for a simple pole. And these two are pole of order 2. Similar way, if it is cubed, this will be pole of order 3 and so on. So sometimes if you're lucky, you get so simple questions. Find the pole, okay, let's say minus 1. What is its order? What is the order of the pole minus 1? These kind of questions also sometimes comes. You have to just know the definition. You don't need to do anything, right? You straight away look into this. Minus 1, power is 2, so order is 2. That's it. Done. But then don't get confused here. This is z square plus 4. So z square plus 4 means you can just do it to 2i and minus 2i. So these are simple poles. Okay, 2i and minus 2i are simple poles. So because 2i and minus 2i are not the same. Okay, so using this you can actually solve it. So please try solving this and tell me what are the residues. Okay, so how many residues you are going to get. You are going to get one for this, so r1, going to go for this minus 1, and then you're going to get a residue for r2, which is 2i, and then another residue r3, which is minus of 2i. Okay, try doing this, check the formula, and that's it. Okay, if you have already taken a screenshot of this or already you have written this, I will just go back to the first slide. Okay, and there you can check. Okay, just what I will do now is we'll just take the function, and my function is uh, if I look into the pole, it is z minus plus 1 square into fz. Right, that is how you write down the formula. So if I just do it, I can just simply write it down in this way: limit z tends to minus 1. Okay, and this is 1, right, and this is d dz of z plus 1 square into fz, and I will write down the function. Let me just check what was my function. Function is z square minus 2z divided by z plus 1 square into z square plus 4. So that's my function. So I'll just cancel this out. And this is a u by v form, and all of you again you have to just recall this. I hope you all of you remember this. Okay, when you take u by v form, that means you take v square at the denominator, so you can do z square plus 4 whole square v square, and then on the numerator it will be v, that means z square plus 4 into d dz of u is at the numerator, right? So d dz of u means d dz of z square, that is 2z, minus d dz of 2z, that is minus 2, plus you have to take u outside, so this is z square minus 2z, and then you take the d dz of v. So d dz of v means this is 2z plus 4. So preferably you don't need to simplify anything. 2z plus 4, not 4 plus 4, sorry, just 2z, just differentiating 2z here. So preferably don't need to simplify it. Directly put the limit values. I think this will make things faster. I always usually do that. There's no point simplifying this. So minus 1 square is 1 plus 4, that's whole square. This is 1 square, so that's 1 plus 4. This is 2 into minus 1, so that is minus 2 plus z square, that's 1 minus plus 2, this is minus 2. Right, I hope I'm doing it correct. Let's see. All of us should get the same thing. This is 1 plus 4, 5, 25. And on top it is minus 4, 5, minus 20. This is minus there. 2 plus 1, 3, 3 into 2, 6. So it is minus 26 by 25. So the first answer that you got, probably you just made some mistake. It's not minus 14, right? It's minus 26. Just check it. I may be wrong, but looks okay to me
Sir,
here.
I'm also getting minus
I got
14
minus
by
14.
5.
Uh-huh.
Sir,
Sir, minus 14 by
Sir,
5 I also got.
sir, answer is
Same.
minus
I also
14
got
by
minus
5.
14.
So
sir,
that means
minus
I did
40
some mistake,
25
it
is the
seems.
Sir, in
answer.
the
Sir,
numerator,
you
the second term is with
yes,
minus sign, actually.
yes, sir. The first one will be the minus.
In the numerator, the second term is in minus. Oh, you're saying
It's
this one,
with
right? Oh,
minus sign.
sorry.
Yes, sir.
Sorry. I used the formula wrongly, correct? Yeah, this is minus. Correct. Absolutely. This is minus. Yes, yeah. ये minus हो जाएगा. So this will be minus plus. So this is minus 14. Correct. Yeah. So that answer is correct. So this is actually a pole of order 2. If you take a simple pole, it will be even more easy, right? So I really don't want to do it. Whatever answer you said should be correct. I solved it actually, okay, and maybe जल्दी जल्दी कर देते हैं पर सबके लिए. So all of us should be at the same page. I'm sure that others are doing it, okay, because everyone did not answer me this, but I hope you've done
Sir,
it,
I
okay.
got for,
Yeah,
sir, for
you got
residue is
this.
equals to Z. Yes, sir.
Yes, okay, so you got it for the second and the third one, right?
Yes, sir.
Okay, that's
And
good.
I also got the same answers.
Okay, same answer. That's good. Yeah. No, as I said that I'm not doubting that you're not doing. I know you're doing it. Okay, but sometimes there are 16 students in the class, so I have to just confirm. That's very important. So I hope all of you are doing it. That's very important. First to last. So this gets cancelled, and then I put 2i. So I'll do it directly. 2i square. So that's 4, and I square is minus 4. Then minus 2 into 2, 4, 4i directly. This is z plus 1 whole square. So that means this is 2i plus 1 whole square. I remember there is a term like this. And this is z plus I. So 2i plus 2i is 4i, right? So you can simplify it in different ways, but I won't simplify it much, okay? इतना trouble लेके फायदा नहीं है, because whatever you write, the simplest form might be just cancelling it out and leave it there and there, okay? Minus plus, let it be there. So I'll just take out that 4 and then cancel it out. Minus 1 minus I divided by this is I, and then 2i plus 1 whole square, okay? If there is not a multiple choice question, I leave it here and that's it. That's my answer. Okay, I don't need to worry much about it. Don't need to spend much time. So the answer that you've given is I minus 1 divided by, yeah, this should be correct because multiply with I numerator and denominator. So you get a minus 1 here. So you'll be getting I minus 1 because that's plus. Yeah, it looks correct to me. Okay, so that's fine, right? You can do it. Fine. If you don't do it, you get this. Then also fine. Not a problem. Okay, same thing. In a similar way, you can find out R3. Okay, so R3, what I am getting is this. I hope I am doing it correctly. If not, maybe you can just check it once. Okay. 1 minus I divided by I into minus of 2I plus 1 whole square. Okay, so that's what I got. All of you please check. You can always
Yes,
multiply
sir.
with minus I and plus I. I think this is correct, right? Is it correct?
Yes, sir. Yes, yes, sir.
Yeah, it looks correct to me. Yeah, okay. Okay. So these are the three residues that we have. Okay. Uh, Let me just leave you with some more problems. Okay. Today we are not going to have classical mechanics, by the way. Okay. I'll just do mathematical physics for a few days now. Most to do it. Okay. Anyway, don't worry about the syllabus. We are going to cover everything. Find the order of each pole and solve. Okay. So the question is something like this. Okay. Oh, okay. Let me just take a problem on infinity, maybe. Otherwise, it becomes too repetitive. Okay. Let me take this. Find the residue at infinity. So one problem on infinity. I think it is the simplest one. Okay. The question would be directly asked that you have to find out the residue at infinity, and you'll be just given a function, and you have to just use that formula that we have written, and that's it. Okay, that's the term. This thing. So this is z square, z minus a, z minus b, and then there are certain formulas in limits that we actually use to check when we actually take the limit to be infinity. Okay, so those formulas you have to recall. However, in this particular problem, you don't really need to remember any kind of formula. It is a very simple problem. Z tends to infinity minus z f z, right? So it is minus z f z, right? So z square is already there, so it will become z cubed, right? And at the denominator you can take out z common, and then you can get that rid of that z cubed here. So z, this is minus z into z square, that is z cubed, that is my z, divided by z minus a, z minus b, z minus c. That means I can take z from each of them. I can take it from here, take it from here, take it from here. So it will be z cubed, and this would be 1 minus a by z, 1 minus b by z, 1 minus c by z. So whenever I'm putting a limit as infinity, I have to get rid of that term which actually makes the entire limit infinity, which I don't want. So I've taken that z out, so this gets cancelled, this gets cancelled, and the a by infinity is 0, b by infinity is 0, c by infinity is 0. So once I put the limit, I should actually get the answer to be minus 1
Minus 1.
divided by 1 into 1 into 1, right? So it is minus 1. So that should be my answer, right? So when it's infinity, it's simple. Sometimes if you're given a sine function or a cos function, then you have to use those properties where you write down sine of n by n of n tends to infinity is equal to 1, and so on. Okay, so those properties might be there, which you need to use, and this is something which is expected that you already know. Okay, so that's there. Okay, let me now give you one problem to solve. Okay, the question is integration z cos z divided by z minus pi by 2 whole square dz. Okay, and you have to solve it, and the contour is z minus 1 is equal to 1. Sometimes just to make things easy, or if you know the way to do it, this will be given in such a way that straight away you look into it and you see that the pole actually doesn't lie within it. Okay, so straight away task with kind of questions where I'll give you, let's say, a 2 marks question there. Then you have to explain why it is 0. That's important. And in exam, competitive exam, you just have multiple choice question, just take the right answer, that's it, nothing to explain there. Okay. So I will actually give you one more sum to do. Okay, and I will give it to you as a homework. Try doing it and tell me the answer next day. Okay, not very much, something which is too new, might be something similar, you can say. Okay, it's not too new. The question is this. Okay, you have to find out this, and the same thing, you have to use Cauchy's integral formula. Okay, I'm not telling you to, oh sorry, the Cauchy residue theorem, don't shift from there. We're doing Cauchy residue theorem, so even if I have not asked it, it's obvious doing that topic. 12z minus 7 divided by z minus
So, sir,
1. Yeah,
which formula we have to use here?
this particular question that I'm giving,
Yes, sir.
same
If nothing
Cauchy
is,
residue theorem.
sir, if nothing is mentioned, then we can use as per our choice, no?
Yes, Cauchy's integral formula you can use. You can do normal integration also, obviously. Okay, but here it's not the case because we are in a class where we have to solve it using Cauchy residue also. You try both and check whether you get the same answer or not. That can be done. Okay, that's for your own practice. Okay, this is the question. Okay, try doing this.